Okay, so example number 3. More examples to help you recognize those quadratic-like equations. So now what we have in here is we want to solve for x again. And the equation we're having here is going to be 4x to the fourth equals 13x squared minus 9. Okay. So now for this equation, once again, before we can start out with any substitutions, what I can see here is that I'm gonna need to rearrange all the terms from the right hand side and bring those all to the left hand side of the equation. So what I need to do is I'm subtracting 13x squared from both sides, okay, and I'm adding 9 to both sides at the same time. And here I'm going to end up with 4x to the fourth minus 13x squared plus 9 equals 0. Okay. So now for this equation here, once again, if you're looking at the form of the equation, even though it's a different equation still, but it's just follow the exact same behavior as we have had earlier with the last two examples. Now here we have it starting out now, ignoring that 4 right here, but the power for the x, it started out being a fourth power, and then for the next x term down, it's just simply halfway down for the power, and there's no power for x. So what I'm seeing here is that it's, as the way I explained earlier, it's still a quadratic-like equation. Now the reason being for that is x to the fourth, you can rewrite x to the fourth as x squared, and here there's a coefficient 4 in front. Now the x squared, the next x squared here, treating that as one singular variable, and plus 9 equals 0. So now at this point, see my repeat of the variable is here. The x squared is the repeat. So now it's clearly that I need to make the substitutions for the x squared. So I'm using the t as the external variable to make the substitution for x squared. Here's my substitution point. And so I mean, after the 3 examples here, throughout the last 2 examples, and here in the kind of middle of the 3rd example, you can see that the candidates to be substituted is always the ones that, after you recognize the pattern of some power, and then halfway down you can all, when you rewrite your equation in this form right here, when you see the repeat, like that repeat variable is going to be the one to be substituted. And so my equation after substitution is going to be 4t squared minus 13t plus 9 equals 0. Okay? And so at this point, once again, let's say we're going to turn direction a little bit differently. Let's solve for t for now. Okay? So solving for t, this is how we do it. Now, once again, it might be a little more challenging than those previous 2 examples. However, we can still factor this quadratic equation here. Now I can see that I can do that into 4t minus 9, sorry. And then here I have a t minus 1. And that's how I factor my 4t squared minus 13t plus 9. And so now in this problem here, after you factor, okay, so after you factor, so now immediately that's going to produce for you 4t minus 9 equals 0, and the other equation is t minus 1 equals 0. And so to solve for this equation, now the left hand side here needs a little more attention. You need to add 9 to both sides, and that gives me 4t equals 9, and dividing both sides by 4, that gives me t equals 9 to the 9/4. The other equation is simply the solution here is just t equals 1. But now, keep in mind, these are not the final answers of us here. It's not the final answers of ours here. Because at the beginning, we want to solve for x. That's the whole goal of the problem. Now here, all of a sudden, we turn directions over to t, so that means at some point, we need to return to the substitution point. We need to return to the substitution point and look back at what's the meaning of t. So t, we claim t on one hand to be equals to x squared, and now we found the actual value of t to be 9/4 or 1. So that means we're producing for ourselves 2 sub-equations. X squared, meaning x squared on one hand equals to x equals to 9/4, or on the other hand, x squared equals to 1. So at this point here, now we can just simply use the square root property to solve for x again. So x equals plus and minus square root of 9 over 4, and the other equation x equals plus and minus square root of 1. So now on my left hand side right here, x equals plus and minus 3 over 2. That's the result for taking square root of 9 over 4. And then the other x solution of yours is x equals plus and minus 1. So altogether, your solution is going to be 3/2 minus 3/2, 1 and negative 1. And these are all the solutions we have after we solve these equations. After we solve the quadratic-like equations, 4x to the 4th equals 13 x squared minus 9. Alright, so now in example number 4, let's say things are going a little hard to recognize. Now, my equation here, we want to solve for x. Once again, solve for x. Okay, my equation here appears as x to the 2/3 power. Okay, minus x to the 1/3 power minus 6 equals 0. Okay, so now we're not looking at those polynomial equation any longer. However, here I can tell you it's still a quadratic-like equation. Now, where can you see that behavior? Isn't it the 2/3 right here, the 2/3 fractions, the 2/3 exponents and the 1/3 exponents? What's the relationship between the 2/3 exponents and the 1/3 exponents? Isn't it still true that 2/3 is twice as much as 1/3? So that's a good thing. Even though at first when you're looking at rational exponents right here, it makes you think that you're going to have to encounter solving some of those rational exponents equation, of course, but much later on. So for now, how do I recognize, once again, how do I recognize all this here as a quadratic-like equation? The key here is the 2/3 power. It started out, the first term here is x to the 2/3. The next power is only a 1/3, so it's still a halfway down. So it's, once again, as I'm pointing out, I hope you can recognize that it's just following the exact same behavior as we had earlier. So now I can rewrite the first power right here, x to the 2/3, I can rewrite that term as x to the 1/3, because I recognize 2/3 is double of 1/3. So I can rewrite this first term here as x to the 1/3. But then I'm going to square that. And now minus, the next term is x to the 1/3, just that. So now here's my repeat. X to the 1/3 is my repeat of the variable, of the expressions. And minus 6 equals 0. Okay, so now my equation here at this point, as I have pointed out, we have a square power of some expressions, and then we repeat that same expression without the square, and then here's the constant term. So that's why it's quadratic-like. So now here's my repeats, x to the 1/3. So now I'm ready to make my substitution. This time, I'm not substituting I'm not substituting t for x squared, I'm substituting t for x to the 1/3 power. And that is going to be my substitution point. Okay, so now, substituting t for x to the 1/3 power, my current equation now would become t squared, because anywhere you are seeing x to the 1/3, that is replaced by a t. So now the first term altogether with the square, it's become t squared minus t minus 6 equals 0. And so now at this point, once again, clearly everything is a quadratic equation in terms of t. And so at this point, once again, I am going to switch direction a little bit. Now, let's turn over to solve for t at this point. And once again, the best method for me, but you can solve this equation using any of the methods you like that I've showed you in 1.5, and you can do that with the quadratic formula, or you can use that using complete the square whatsoever formula that you want to do. Here, factoring, it gives me x minus 6 and x plus 1. That's how we factor it. And so immediately I'm going to produce x minus 6 equals 0, and I'm sorry to say x, but I meant t. And t plus 1 equals 0. So with these two equations, I'm ready to solve for t. One value for t equals 6, the other value for t equals negative 1. And once again, please keep in mind that we are solving for x, not for t. So here is not our final answers yet. T equals 6 and t equals negative 1 is not the answer to the problem. So I need to move further. Now, I need to look back at the substitution points, and what I'm saying here is t itself is actually equal to 1/3 power. So what that means, t itself equals to x to the 1/3 power. So what it means is, at the same time, on one hand, x to the 1/3 power is set equals to the value 6 that we found for t. And on the other hand, x to the 1/3 power can also be equals to negative 1, as we have found negative 1 is the other possible value for t. So now, what it says here is that, so now with these new equations, here things go back to those equations that you need to solve involving with the rational exponents right here. And if you're not sure how to do this, once again, check back with my videos I've had earlier about how to solve rational exponents equations. But what I'm doing here, simply to solve for x. X is equals to 6 to the 3/1 power, which is technically 6 to the 3rd power. That's what x is. And do I need to worry about the plus or minus? No, because the numerator for my rational exponents here is an odd number, so I don't have to worry about the plus or minus. So 6 to the 3rd power, I'm leaving that for you to calculate, but it should be a computable number. The other number here, once again, x equals to negative 1. I'm raising all that negative 1, the whole thing, the whole number there. I'm raising that to the 3/1 power, and that makes it x equals negative 1 to the 3rd, or simply negative 1 again. So that's my other answer. So now, in this equation, I found two answers. And that's how I finished solving my quadratic equation.